right. I guess it's time to start. So thank you for joining to this event. That's event co-organized by both Zenika and Oracle. So thank you, Derek, for making this happen as well. It was quite unexpected because we knew each other from before as well. And I think it's a very good topic, GraalVM, and I hope that we can share a lot with two very, very good speakers on that aspect. And yep, Derek, please, if you can
Thank you for inviting us to this call. It has been an honor to work with you guys. I know you guys have been doing well. You guys are in the market doing all this microservice, agile development. You are basically best in class. I'm honored to have the chance to work with you guys again. So this is like the second or third time I'm doing a night class with Zenika actually. So hopefully on this session, we get to share some good topics with everyone and everyone get to go back learning something new today. So I think from our end, we have Oleg, who will be talking about executable microservices, which is, I think, a very important topic recently, especially. And then we have another speaker from Zenika as well, who will follow up with talking about the monitoring and stuff. So maybe Adrian can...
Yeah, so I think we're going to get started directly. So I will put you both, Oleg and Loïc, on display, and you can present yourself, and then we can start with Oleg. Thanks.
Right. Hi, Loïc. Hi, everyone.
Hello.
My name is Oleg Šelajev, and I work as a developer advocate for the GraalVM team at Oracle Labs at Oracle. And I'm very happy for this opportunity. I was in Singapore once, and I absolutely loved it. And in these challenging times, I'm happy that, at least in spirit, I could be with you.
Hi, I'm Mathieu. I work at Zenika in France. I'm working as an IT consultant and as a trainer. And I'm very happy to talk to you about how to monitor and troubleshoot GraalVM native executable. And I'm happy to be part of this talk with Oleg that I already met at Debug last year. I don't know if you remember, but yeah, this was cool. And yeah, cool. I'm sure this will be a very interesting talk.
Right. Was the introduction done?
Yep. So I think we can start. So Loïc, I will just put you backstage just for a while. See you later. Okay, and Oleg, the floor is yours.
Thank you very much. I am sharing my screen. I hope people can see my screen. I'm not sure. Yes, people can see my screen. Excellent, excellent. What a setup we have here. Yes, my name is Oleg. As I said, I work at GraalVM. Almost universally in the internet, I go by @Šelajev. So if you have questions that you want to ask, you can just find me on Twitter or email or follow me on GitHub or anything like that. There is also an opportunity, of course, to ask questions right here. So if you put them in the chat, I think I would be absolutely happy to answer them. And I would absolutely love it if you have a question, just type it in chat immediately as you have. Don't like write it somewhere in a piece of paper and then ask later after the session because you might forget. And I will try my best to judge whether I should answer the question immediately or whether this is something that I need to postpone until the kind of later time, right? So hopefully this is an educational session. We're going to talk about fast and efficient microservices with GraalVM, targeting mostly Java developers and talking about the Java applications and applications running on the JVM. And let's get started. This is a technical presentation, so don't make any forward-going business decisions based on the contents of this. And also note that GraalVM native image is available under the early adopter status, so be mindful of that. GraalVM in general is an excellent project, and it's a very ambitious project. It's a high-performance polyglot, embeddable virtual machine that is capable of running programs in different languages. That's quite a bit to unpack there, so let's go with. High performance is fairly easy, right? The GraalVM as a runtime, it tries to be fast. It tries to execute your programs fast, and it's sort of self-explanatory. It's very important in the current age and time where we run our programs in the cloud, but it's kind of the easiest to understand. The polyglot part is that GraalVM can execute programs in different languages, and there are a number of them that we support currently. JavaScript, Python, WebAssembly, LLVM, Bitcode, R, Ruby, just to name a few. And embeddable means that you can take GraalVM technology and put it into your Java or native applications. So you can make your application understand and evaluate and run JavaScript or Python without making it, without having to run a separate service for that particular language. So those three main things are also the three main virtues that GraalVM can offer to Java developers, right? If you're running on the JVM, if you write programs in a JVM language, then GraalVM can offer you a couple of things, right? So we have also a question from Eska. Can GraalVM bring any improvement in performance rather than fast startup and fast shutdown? Which is an excellent question. And we're going to spend a couple of minutes in this presentation talking about that. So at the core of GraalVM, at the heart of GraalVM, is the GraalVM compiler. Normally, it can be used as a just-in-time compiler inside your Java process. This is a very good compiler, right? I can be a little bit biased, right? But I think it's a great compiler, and it shows really, really good results on a variety of workloads. So you can run your Java applications normally as you run them. You can run them on GraalVM, make use of the GraalVM compiler, and get better performance for your Java applications. And this is not talking about startup or shutdown or memory usage. This is talking about pure throughput, where the JIT compiler just generates more optimized machine code, and your application just runs the same way, but faster. The second pillar here, and the second value that GraalVM can offer specifically for Java applications, is the ahead-of-time compilation through the native image technology. When you use that, you feed your Java applications, you process your classes of your application, and GraalVM compiles them ahead of time into the platform binary. This binary then has a different performance profile from running with the JIT. Namely, it will be pre-compiled, so it will start really fast. It will use less memory because it doesn't need to compile anything during the runtime. And it will also shut down fast. So you have both of them as options. And also for Java developers specifically, there could be very interesting to introduce another language into their applications. You don't have to do that, but you absolutely, if you have a need, you can. So we have a state-of-the-art JavaScript engine, which is compatible with modern ECMAScript standards, like ECMAScript 2020. It's really fast. Also, it's comparable in speed to V8, which could be seen as a default runtime for JavaScript. We have Python, so if you want to maybe introduce some machine learning into your application, you don't have to rewrite it in Java, but you can maybe use the Python code that does that. And other languages. So you don't have to make your application polyglot, but GraalVM offers you and opens the ecosystems of other languages. So you can use the libraries as they come. In this particular presentation, of course, we're going to concentrate on the first two, running with the JIT, because that can make your Java applications fast, I mean faster, right? So that is the fast and efficient microservices. That's the fast part of the title. And also, we're going to talk about the native image compiler. And Loïc will follow up talking about the native image executables, which is sort of the efficient part of the fast and efficient microservices in this session. How can you get started with GraalVM, and how can you experience all it can offer? It's very simple. And specifically for Java applications, it's absolutely straightforward. You download GraalVM, you can go to the graalvm.org/downloads. We currently offer the distributions based on JDK 8 and 11. So GraalVM distribution contains a compatible JDK, right? So you can unpack it, you can put it on the path, right? I have no slide, and then you can run your Java applications normally using the Java utility, and it will use the Java utility from the GraalVM distribution because you put it on the path, right? And your applications will run potentially faster. So if you have a second, I would absolutely love, so we have the distributions based on Java 8 and Java 11. If you run either of those, can you please type in the chat which one you normally use for your production services? And if you use anything newer, unfortunately, we don't have the distributions yet for GraalVM on, say, JDK 15. But I would also love to see that in the chat because then I just really love to survey the ecosystem of the Java versions people are using. So 8.11 out of the box, get the download, run it, and it will work. How it will work? So when you run that Java -jar executable from GraalVM, it starts the normal Java hotspot VM process, right? So that means that it's a normal JVM implementation from OpenJDK project. That means it will do everything that the normal JVM does. It will start up, it will initialize its own things, it will use the normal GC implementations like G1, GC, for example, as a default in Java 11. And then it will integrate the GraalVM JIT compiler, right? The compiler that I was talking about, with that JVM process. And it will integrate that using JVM CI, which is the Java Virtual Machine compiler interface, which is the normal way how you integrate third-party JIT compilers with your Java hotspot VM. It was added to OpenJDK in Java 9. We backport that to Java 8. That's how you get the GraalVM distribution based on Java 8. And I can see in the chat, Loïc says that he runs Java 15 in production. Well done, Loïc. Well done. This is not the typical response I get on the sessions. Normally, people run a little bit more mature releases of OpenJDK. Right. So with those two layers, right, with Hotspot VM and the Graal compiler, what we can do, we can run all Java applications normally, right? So anything that goes through Java bytecode can be run on GraalVM. The GraalVM JIT compiler eventually will kick in, right? There is a tiered compilation system normally out of the box in the Hotspot VM. So at some point of time, the VM will come to the JIT compiler, and the GraalVM JIT compiler will sit as the top tier, most optimizing just-in-time compiler, right? So eventually the code will get to that, and it will look at the bytecode and output the machine code, and your application will be faster. This is the same thing that OpenJDK runs, and GraalVM replaces the C2 JIT compiler in the OpenJDK distribution. For the other languages, right, they don't go translated to the Java bytecode. For the other languages, we need to add other infrastructure. So that comes in the as a truffle framework, which is the framework to implement managed languages. It offers you API to implement interpreters for the languages that you want. And then those interpreters at runtime will get very efficiently compiled to machine code as well, without having the intermediate representation as the bytecode. So there is no JavaScript to bytecode translation. It's just the interpreter gets to interpret the JavaScript program, for example, and then it gets compiled to machine code. So through that, we can run a number of programs, and you can run them inside a single process, right? With the LLVM bitcode interpreter, we can run really fancy things, right? So first, yes, we can run Doom. Everything can run Doom nowadays, and GraalVM can run Doom as well. And also we can run other programs that compile through LLVM. So for example, recently we published a blog post how you can integrate a COBOL application and rewrite a part of that in JavaScript. So re-implement a piece of logic of that large application in JavaScript and make it work within the same process on GraalVM as you were running it before. So I think this is a little bit unexpected use case, but I think it's very interesting that there is such a synergy between the technology from 1959 or whatever, whenever the COBOL was designed and published, and the current popular languages like JavaScript. And it also allows us to maybe move COBOL programs further without rewriting them from scratch. So this is how it works. Your applications will run normally and they will run fast. And why do you care about that? Because performance is money. Specifically, when we run in the cloud setting, performance means, well, faster runtime means faster applications. Faster applications means you pay less money to the cloud vendor, which is very important. And think about that. There is a scale, right? There is a scale where the amount of money that you pay to the cloud provider accumulates. For example, if you run something large, if you run something web scale, then you probably care about all performance improvements that you can get. Twitter is one company that uses the GraalVM technology. So they use the GraalVM compiler that they put in their own builds of OpenJDK to run their Scala microservices. And they're very happy because they get good results. They see the dropped CPU usage. They see better latency because GraalVM compiler is really good at the escape analysis. So it can eliminate allocations and reduce pressure on the garbage collection. So they see less GC, they see better throughput, and they are very happy using the GraalVM compiler. And you can do too. So you can watch. There is plenty of presentations about how Twitter uses the GraalVM compiler, how they tune that with some machine learning. It's very interesting. Chris Tallinger is one of the Twitter VM engineering group people who talks about that. Another use case, for example, is the cloud vendor itself, right? Oracle Cloud Infrastructure at some point of time last year migrated some of the services, telemetry services, to GraalVM. They saw better peak performance. They saw less time spent in garbage collection, and they had no problems migrating that. How we know that it's not just a fluke? We run benchmarks, right? We run a ton of benchmarks, and we see that GraalVM is better on those benchmarks. One benchmark suite that I can recommend you to look at, besides the normal ones, right? So, like, obviously, you should look at the results of like Da Capo or Spec JVM, Spec JBB, and so on. But one benchmark that I really like recently is the Renaissance benchmark. Why? Because it's a benchmark suite, and it consists of benchmarks from other projects which are modern Java libraries and frameworks that currently you might be using in your applications, right? So you can see there at the bottom, there is some Akka, there is some, I don't know, there is some Dotty, which is the Scala compiler. If you run Scala, there is some Neo4j Analytics, which is the Neo4j is the graph database, of course. There are some reactor streams. There are some reactive extensions, right? So there are things that are popular recently in the ecosystem and that you can use in your applications, right? Very, like, not often we write code that uses like low-level math, but very often we write code that uses other libraries, like, for example, reactive streams. So benchmarks on those actually mean quite a bit, right? And you can see, so this is the speed up of GraalVM Enterprise Edition based on JDK 8 compared to JDK 8. You can see that there is quite a lot of improvement. And think about this way, right? Every percent matters, right? Like even if it's like a few percent, like 10 or 15, that is quite a bit of improvement. So JVM is a very hard, a very smart virtual machine, right? So making it more performant is a big deal, right? And also think about that 2% is, or like 4% is a lot, right? Because what? Over the longer time period that accumulates, right? 4% is, I don't know, one salary every 4 years. So if you are not willing to drop one salary over 4 years, then you should take care of those 2% or 4%. Right, so what I'm trying to say, all improvement is good improvement. And another thing that I want to say here is that specifically, there is no better indication how a runtime will perform and what performance improvements you'll see, except running on your own workload. So there was a question from Chang in chat. How does GraalVM compare to Zing from Azul? Unfortunately, I don't know. I think Zing is a proprietary product, and the license terms do not, like, I haven't seen, I don't know, right? I haven't seen any comparisons, and I don't think it's even possible under the licenses how you can get Zing, right, to see the comparisons. If you really, really want an answer to that question, you can maybe email me and we can try to figure it out more privately, right, so to speak. But honestly, I don't know the answer. I think GraalVM is the best runtime that you can currently get, but it might depend on your workload as well, right? That's my personal opinion. But let's get to the cloud, right? Because we run all the programs in the cloud, and while running them on the faster JVM is good, and you should absolutely do that, specifically if the migration path is so simple, right? The cloud often means a different deployment model, right? In the cloud, very often we don't run our services for ages, right? We pack them into the ephemeral small containers, We give them very little resource, right? Literally like megabytes of RAM and maybe half of CPU. And we want them to run, and we want them to run and serve business requests, which is a completely different way of thinking what the runtime should do when compared to the deployment where you put an application, maybe pack it into the application server, give it plenty of resources like gigabytes of heap, maybe like dozens of gigabytes of heap and ton of CPU, and then run it for ages, right? In this ephemeral deployment model, the worst part is that the containers are managed very often by someone else, right? Usually your Kubernetes engine or your cloud provider, and then they can come and go at any given moment. So very often there is two things. There is not enough time for the JIT to warm up, and there is not enough resources for actually JIT to warm up, because if you give your application just a bit of memory and a bit of CPU, and it needs to actually serve the traffic, it also cannot it cannot process this quite extensive task of compiling your application at runtime. So this is where, if we talk about performance, what the performance means, what means like better performance. My application has better performance than yours, or like my runtime has a better performance than yours. What does it mean? So normally, very often, it means peak throughput or better latencies, right? This is what the JVM was optimized for years. But in the cloud, right, to the left of this red line, yes, to the left for me, and it's also to the left for you as well. To the left of this red line, there are the characteristics that are more important for the cloud deployments, right? So we want really good startup speed, because we want our applications to be auto-scaling on demand. We want lower memory footprint, because we want to put them very neatly into small, tight Docker images. And we want sort of small packaging, because we want to send our application over the network, and they will be running on virtual machines and automatically deploying, undeploying, removing from caches. There is no individual operations handling the deployment of every single service. And those are really great for the microservices, right? But there is this distinction. Of course, we would like all 5 of those to be great, right? That would be excellent. But traditionally, there's if you run your application for months, you don't care about the startup speed mostly, right? It just doesn't matter, because you can, if you run it for a month, you would know that it will warm up nicely. You can pre-run it like a day before, run the traffic through it or sample traffic, make sure it's all warmed up and everything, and then you only care about the peak throughput. if you run it in a large container environment, or not container, in a large like heavy beefy machine, that they don't care about the low memory footprint, right? I run some of my applications on a virtual machine in the cloud with like 100 gigabytes of RAM, and I run my command line application there. I couldn't care less if it takes like 300 megabytes of RAM or if it takes like a couple gigabytes of RAM, because I have plenty of resources there. So there's just not a question that I need to bother with. But as soon as I start packaging them neatly, right, then that it becomes a problem. And then I need to care about the memory footprint and startup speed. So the good thing is that that distinction is very well served by either running with the JIT, and hopefully with the best JIT you can find, or running in the ahead of time compiled mode, because it naturally just serves that. Ahead of time compiled mode gives you startup speed, gives you memory footprint by not including the JIT and small packaging. And the JIT gives you the peak throughput because it can optimize, it can speculate about the code execution. So it can de-optimize and optimize again if the conditions change. But when it speculates, it can produce really, really good machine code. And also the latencies are the reverse of the throughput. So with good throughput, you get good latency. And currently, specifically in the GraalVM case, the ahead of time compiled executable is a little bit less fast when we talk about peak throughput than the warmed up JIT. Doesn't have to be, but it currently is. So, and the important part here is to recognize that GraalVM gives you an option. GraalVM gives you a choice whether you want to run with the JIT or with the ahead of time compiled mode, right? So when you run with a ahead of time compiled mode, your microservices, your services become very efficient. So here I have an example of a Micronaut application, a screenshot of an example of a Micronaut application that I can run given it heap of 64 megabytes, and it starts in 70 milliseconds. Why those particular numbers are important is because when you run in the cloud, typically you are built for the amount of resources you spend, for the amount of time you spend them, right? And there is a step function, how much money you pay for the resources, and normally the smallest like unit that you can kind of sort of rent, right? Specifically in the serverless environment, that would be like 128 megabytes of RAM, and they will be billing you by 100 milliseconds. It depends on the cloud provider, of course, but like that's sort of a general picture, right? So there are diminishing returns after you get to the heaps lower, not heaps, the memory usage lower than 100 megabytes and startup lower than like 100 milliseconds, because you still pay for those chunks, right? So of course you can optimize it further, right? And there is a trade-off. So you can give it more resources and it will be faster. But I wanted to show you that a GraalVM native image can compile a microservice very easily for those small environments. How it works, it takes your application classes, it takes your dependencies, it takes the Java runtime classes, it takes the GC and runtime implementation from the project substrate VM in GraalVM. That old part on the left is written in Java, and then it looks at that, it initializes the application, it takes the snapshot of the code that was reachable and the object that were created during the initialization and writes it out into the executable, right? So in the final executable, you have both the code ahead of time compiled, of course, and the data from the pre-initialized application, which makes it very efficient at startup. It operates under a closed world assumption, which means that it needs to see all the bytecode of your application when it actually builds the native image. The obvious trade-off for this is that there is no loading new classes at runtime, because you need to see all the classes at the image build time. And that means that some applications or some models of running applications are less suitable running as a GraalVM native image. It is possible because there is the initialization step, right? As I said, like your application gets initialized. So you can load all the new classes, all your plugins, all your starters during this build step. And then kind of take the compile stuff after. But at the runtime, there is no facilities, like the class loading and the bytecode interpreter facilities are not included at runtime because they're not necessary, because all the bytecode has been seen. So that is a plus, right? That's how we get lower memory footprint. The unused classes and methods and fields can be removed because we saw all the bytecode and we actually know what is used and what is not used. And it also allows us to aggressively optimize ahead of time. For example, if there is no new class loading, there is no class hierarchy changes. And that means that we can sometimes, if you have an interface with a single implementation, for example, or we know that into a particular method comes only a single implementation of the interface, we can, for example, link directly into the methods of that class rather than invoking virtually through the interface. So that gives us the speed, right? And another downside of that, not the downside, the trade-off is that some dynamic parts require configuration at build time. So if you want to serve resources, or if you want to access some classes through reflection, which works well, but the static analysis that is run cannot process that automatically, because you dynamically can construct the class names that you want to access, or the resource passes that you want to access. So you need a configuration that says, this is my resources, I want you to include them. Those are the classes I want to use through reflection, right? That configuration can be provided by a Java agent. So you run your application normally with the Java, with it on the JVM, and you provide the Java agent, and it will output and record the configuration for you, which is very good. And then it will run and build and be a nice ahead of time compiled executable. And it will give you a great result. It will give you, like, you can run a small thing with memory in like low tens of megabytes and actually serve business requests on top of that. And you can see that CPU spikes, there are only tiny things where you actually serve the requests. That is AUT on the left. In the JIT mode, you can see much more CPU, right? You obviously see more memory usage, but you also see more CPU, which means if you pack it into Docker environment, into Docker container, and give it like half a CPU, that those red spikes will mean that you have to wait longer. There is a number of frameworks and projects that support GraalVM native images in the wild. There is Halidon, there is Micronaut, which I like personally very much. There is Quarkus, of course. There's a Spring Boot applications where the work is going forward to enable the native image support. There is a Pico CLI for the command line applications, and the ecosystem is growing. And if you're specifically interested in Spring, I can recommend you to watch The Path Towards Spring Boot Native Applications by Sebastian Deluze and Andy Clement, where they talk about the work that has been done and the current status and how some applications work, some starters for Spring Boot currently work, and the path forward, which is a very interesting session. You should watch it, right? I like Micronaut because Micronaut offers you the normal things that the framework offers you: dependency injection, AOP, configuration management, bin introspection, and so on. But it also makes use of the annotation processors to process your application and to generate configuration and dependency injection and build everything, right, at the compilation step before your application even hits the bytecode, right? So that is an excellent idea, and that works really, really well with GraalVM native images. So here I would like to show you a demo of application, but I'm not exactly sure how much time I have. So I will probably just make it very, very brief. So here, for example, I have my Micronaut application and I run it in the cloud, and the application looks very normally, right? If you have seen Spring applications or micro-profile applications, it's sort of similar. We have the application class where we say that our framework, please run our application. We have some controller files where we specify with annotations that this will be a controller. And my use case here will be running prime numbers, right? How do I build my application normally? This is normal, right? The same way as I do always. So with Java -jar something something, but I can also build the native image here. And while Micronaut provides the support for building native images with just a Gradle task, I just wanted to show you how it actually runs if you run it manually, right? So here's the build script. I run Gradle W build, and I run native image, and I just give the pass to the class pass, say native image process this class pass. Micronaut provides some configuration for you, and then at the end you get the file there. So I have done that before. It will take 1.5 minutes on this machine, but I want to show you this file, right? Primes serial. Right? It's a small file, 70 megabytes. You can compress that with UPX, and it will be around 20. It also links to the operating system libraries. So there's no dependency on the JVM, right? And I can run it. I can run it very well. I can run it very, very fast, right? So it starts up in milliseconds. Here currently 25, and I can open this. I can open this, right? And then where did it open? Yes, it's here. Wait. Oh, it's on the other monitor, right? So I can open it, and you can see that it's the same URL that I specified in my controller, right? And I can hit random numbers, and I get my prime numbers back, right? So I can see I get random prime numbers under 100. Right. Wait, come back. Right. So this was a small example of how you build your application, and the cool part of that, because you can use the native image utility, can configure your application. For example, you can use, if you're using GraalVM Enterprise Edition, you can use the key low latency GC that will build in G1 GC collector in there, and that application will have a different GC algorithm built in. It will still start fast, right? So primes G1, right? It still runs the same way, but it is now using G1 GC, which is adaptive, which can bring the performance of your application higher, right? And then you can also use the profile guided minimizations, which is a very neat trick, right? The JIT collects the profile at runtime, and then it applies that profile immediately. So with ahead of time compilation, you cannot do that. So what you can do, you can say, I want to build an instrumented library, an instrumented executable that I will then apply load to with my scripts, staging scripts, or load tests and anything. And then I will use that profile that was generated from that load application and make a very efficient executable, right? And I won't show the tests here, right? Because there is no time currently. But this optimized thing is much, much better at this particular use case, and normally is much, much better at performance for normal use cases as well. Specifically talking about the peak performance here, because the startup and memory usage will be similarly small for all native images. So that is that. Key, just to follow this up and to finalize, because I have like a few minutes left. You can take the native image, you can still configure how it behaves, right? So you can, for example, configure how much memory you want it to use. If you don't want to run it in a, if you don't want to configure the resources on the container level, you still can choose the GC because it has this adaptive property. So you don't have to tweak your memory usage beforehand. You can use the profile get optimizations if you want better throughput or better tail latencies. And the main thing to think about here is to minimize the container resources consumption to the throughput, right? You can always go and pack it into a very minimal thing, but then the throughput will suffer. So you want to have a sort of balance, right? Which normally means that you want to run your microservice in a smaller container, like giving it like 100 megabytes of 200 megabytes or like around that RAM, and I don't know, half or 1 or 2 CPUs. So like smaller containers, and then scale them using the cloud facilities rather than scaling them by within the JVM. And in general, if you want the best throughput, you want to use the best just-in-time compiler that you can get. If you want the best startup and memory footprint, you want to use GraalVM native images for your applications. And of course, yeah, don't hand optimize until you need to, because the compiler is actually really, really smart. So write small methods and you will be all good, and your performance of your applications will be good. There is an Oracle GraalVM Enterprise Edition. If you want a product, it differentiates on performance, so it can get you higher, better performance, small memory footprints. Of course, the enterprise support if you need support, but the compiler in the GraalVM Enterprise Edition is better, so the JIT is faster, the native image generation is smarter, so the native image is smarter, and there are some features like I showed G1, GC there, which are enterprise features only. So if you want the best, absolutely best performance that you can get, you can think about that, or you can use the GraalVM Community Edition, which you can get, and it's freely available under the open source licenses. And you can join the project. You can join our GitHub repository and submit issues and ask questions. You can join our community Slack and Twitter and so on, right? So a ton of companies are using GraalVM currently. They see benefits, and I don't want to say that you need to start using GraalVM right now, but what I would like absolutely to say is that next time you deploy your Java applications or you run your Java applications, you should be aware that there is an option to run on GraalVM, either with JIT or as ahead of time compiled native images, and you should think about that. Thank you very much. This is all for me. I don't think I have time for questions, but there are also no questions in the chat.
All right. If you have questions, you can type them. We will leave just 1 minute before we pass the mic to Loïc.
Right.
Right. Seems,
I see someone responded that they're running Java 8, which is very, very good. Alex, I salute you. I love Java 8 as well. Sort of, I have some sentimental value from that, right? Java 8 was like, it was a great release. Do you remember how you run Java prior to Java 8, right? And how happy you were when Java 8 was released? That was a massive, that was big deal, right? And OpenJDK project, it's a great project, right? The GraalVM builds on top of that. And then, and OpenJDK moved forward quite a bit, and there were very exciting development happening there as well. But the downside of those like fast-paced releases is just, for me, because it's just not as exciting anymore, right? Before, every release was a big deal, right? You were waiting for it, and then you were like learning about it, and then you were migrating towards it. And it was, I mean, it wasn't maybe probably the best for the enterprises, right? But it was very exciting as a developer. And now you're like, oh, Java 14. Do you remember what was new in Java 14? No. Right? Which I don't want to say that I don't want to like minimize or be condescending towards the OpenJDK project. I love the project very much, and I respect the hard work that they're doing. And as I said, OpenJDK, GraalVM actually builds on OpenJDK as well. So there is quite a synergy. But yeah. Just a personal anecdote about how Java 8 is close to my heart. Anyway, sorry, I just feel the pause. There were no questions.
Okay, I think it impacted us, all of us, in a certain way. Thank you very much, Oleg. It was very, very interesting. I guess we're switching to Loïc, if that's okay with you.
No, yeah, it's absolutely perfect with me. I was just, if it's Loïc is fine with it.
All right, let's do that. Hey, Loïc. Yep. All right, so the floor is yours. If you can share your screen, I will add it to the stream. So your audio is still a bit clunky, but it should be fine. We should be able to understand you if you go slowly, I guess. And we'll take it from here. All right.
Hello. How to monitor and troubleshoot GraalVM native executable. So hi, Mathieu. I'm an IT consultant and trainer from Zenika, France. You can find here my Twitter account, my GitHub, my mail, and my blog if you are interested to keep in touch. There is some challenge to monitor GraalVM native executable, and we will discuss them. So first, GraalVM native executable, what is it? Oleg explained, so I will don't go into details, but you can there is a tool inside the GraalVM project that is native image. Native image uses the Graal compiler in ahead of time to generate a platform-specific highly optimized binary. This binary is called a native executable, and this binary embeds a minimalistic VM named SubtractVM. SubtractVM and the native image tool have some limitations. The limitations are dynamic class loading, reflection, dynamic processing. All of these are linked to the fact that GraalVM needs to native image needs to be executable in a closed world in assumption, so it needs to know all the code that will be executed at runtime to be able to compile this code ahead of time. GraalVM have also some limitation on GNI and GVMTI. GVMTI is Java Virtual Machine Tool Interface. I copied the sentence that introduces GVMTI from its documentation. GVMTI supports the full breadth of tools that need access to GVM state, including but not limited to profiling, debugging, monitoring, thread analysis, and coverage analysis too. So we can say that GVMTI is the protocol, the specification that allows to monitor and troubleshoot an application. So how can we do without it? So how can we monitor an application, a Java application without JMX, Java Agent, standard JVM tools like GPS, Gmap, GStack, Java File Recorder and Java Machine Control, Java Profilers, and Java Debuggers. Okay, so first, when I will need to understand how an application works, to start monitoring, start the troubleshooting an application, usually I will use standard JVM tools and Dynamics to access application statistics and JVM metrics. This is really the first step. So how can we do this with native executables? So here I have a native executable. It's a Quarkus application, but it's not important. So it's already compiled with native image tool a lot of times to execute. So I can just launch it. Excuse me. Okay. So it's not very quickly, 18 milliseconds. So I want first to gather some information about the running application. So as I said, I cannot use GPS. GPS will not show my application because it's not a Java application. So I will use PS. Okay. So this is the PID of my application. But to gather some information on it, some statistics, I can use standard Linux tools like the stages. This is a way to have some statistics on our Linux process, but you can see it's not very easy to understand. There is some information about memory usage. For example, here I know that I use 56 megabytes of resident size, so total memory usage of my application, including heap and meta space. So it's really low, but there is not a lot of information. So one easy way to add statistical information about your application is to add a methodology library. So you can use methodology tool like Prometheus and Micrometer, and if you use Spring Boot, Nicola, Quarkus, there is just a dependency that you can add that will enable to generate metrics for your application. For example, I can show you the metrics of my Quarkus application. So I just add dependency, and it will generate metrics for me. So this is Prometheus metrics. There's some application metrics, but what's interesting is that there is some CPU information also. That is some class level information. You can see CPU usage information. There is some GC information, memory usage, and stuff like this. So by adding metrics library, some metrics functionality to my application, I can have the basic information I need to have to start understanding what's going on my application. So with NAT executables to replace GPS with PS, you can access line status information about the PID, but you really should add methodology stuff like Prometheus and Micrometer to your application. So next, I usually get the thread information because most of the time you can find what's going on in your application just looking at what its threads are doing. Usually you use GStack to generate the thread them, or GIMX to gather thread information, which via Visual VM or stuff like this. But with native executables, you can use kill. So if you use kill -3 on your PID, this will ask your application to generate a thread dump on instant console, so you will have a thread dump event. So this is cool. I can have the thread information. Great. So for thread information, you can use kill-3 on your PID, and methodology has also some thread information, so methodology can help. Monitoring. So monitoring memory. So usually when I want to monitor memory, I use JMap to generate a hidden, or I just activate the GC logs and use some tools. I prefer GC logs because it's difficult to utilize, but if needed, it's always a good thing to do when you feel that you have a memory. So with native executables, what can we do? We can have GC logs information. So you use these two GVM options, so clean GC and behavioral GC. And then you can see that if I create some node, so I use the WRK to generate some node on my application, and I can see that there is some GC logs. Unfortunately, tools like GCEasy didn't understand the GraalVM GC logs because this is the GraalVM default garbage collector, and it's not an NGDK standard garbage collector. And unfortunately, memory dump is not available on the community edition of GraalVM. So if you want to take heap dump, you need to use GraalVM Enterprise. So you can have GC logs, and methodology can also help you to monitor your memory. Application monitoring. So with cheaper applications, usually I use some tools to monitor my application. Usually APM tools. So APM stands for application performance monitoring. So it's tools that can monitor your application end-to-end for you, like dynamics, dimensions, data. All these tools are usually based on Java.js or JVM. So you cannot use them with GraalVM image application. I sometimes also use Java File Recorder and Java Machine Control that didn't work exactly. So what can we do with native executables is to use some open tracing tools. So open tracing is the way to trace the transaction of your application. So it can trace your code to your application and generate spans inside to trace. So span is just a portion of the execution of your application. For example, you can have a span for a request on the database. Again, Quarkus have an integration with open tracing, but Spring Boot and Microservices also. It's just adding a dependency, one or two dependencies, because with open tracing you need to have some tracer. So if you want to trace your database request, you need to have a tracer for your database request. So I said I have open tracing already set up inside my application. So if I launch my application and generates some load, this will send traces to Šelajev. And I have a local Šelajev, so I can have a look and I can find traces of my application. So for example, this is the trace of one code to my application. And this trace has two span, and one of those span is the database request. Okay. So with open tracing or open telemetry, like you can have some application monitoring. It's not as complete as that you will have with a tool like APM, but it's still very interesting. If you work on Kubernetes, you can also install a service mesh that will make some tracing between your services. A little like open tracing, but it will not create span inside your service code, because the service mesh is more between your Kubernetes services. Profile. I love to profile applications because it's really a way to understand how it works, and it usually teaches you a lot of information about your application. So when I want to profile application, I usually use a sign profiler, but you can also profile it with Visual VM or ZeroKit. But unfortunately, profilers are based on GVMTI and Java application, so you cannot use them with native executables, but there is a Linux profiler. It's called Perf. So you can use Perf to profile your application. If you need to use Perf, you need to add some options to the native image tool. I will show you the two options just later. So I have my application was built with symbols in it, so Perf and used symbols to profile your application. So I will just show you how to use Perf with your native image. So I need some. Okay. This is the Perf command. I will explain it to you. So I will record. Okay, just excuse me. I need the PID of my application, of course. Okay, so I will use the PID here. So here I launched Perf to record the execution of my application. So sorry, I forget to. Okay. So I will launch it again. So Perf will record will record the profile my application. I use the -if 99 option that will profile it at 99 Hz, so 99 sample per second. Then I use graph call graph. This is a way to tell graph to use the ELS symbols that are inside my Mathieu executables. Then I can use graph to analyze the reports. So I will use graph report for this. Okay. It will take some time. When you launch perf, you can launch perf with your application or ask perf to monitor an existing process. This is what I used. This is why I ask perf to monitor the process with the PID of my application. And if you don't start your application with perf, but you ask perf to monitor a PID, a process in your application, you need to add to the perf command a line command. So this is why on my perf command there is a slip 10 at the end. So perf will launch the slip 10, and at the end of the slip 10, it will generate the profile. So this is my profile. You can see it's a hierarchical profile. It has the Java method naming it, so it understands the Java frame. So here there is a small issue with perf. So there is a small issue with the way perf monitor GraalVM application. On the command, instead of having the name of my application, because the name of my application should be the command name, it has some part of the name of the thread. Okay, I will go back to this later. But this is a small issue, and you can understand later why. So okay, here I can navigate to the perf profile, but I think you should agree with me that it's not very easy to navigate in it. There is a very neat way to read a profile is by generating a flying graph. So flying graph is a way to display a performance profile by creating a graph with the weights of the. I'll show you a flame graph. You will better understand it with an example. But flame graph uses the name of the comment for its root. So I need to just update a little the profiling data to have a common root. So first, I will use script to output the graph result on the textual file, on the text file. Okay, this will take some time, and then I will use two set commands to remove the number on the student name to have a common root for all my flames. Yeah, so this takes some time. So you see, this is not a very huge graph profile, but it's already used a lot of time to process. So if you need to process a huge profile, you need to have a different computer and to have some spare time. So here I just launched two set command to remove the number on the command, the number of the thread to have a common root. Then I can use the flame graph tool. So flame graph is a tool built by Graveland Greg. You can check the website for very interesting information on the flame graph. Then I can open the flame graph on Firefox. Okay, so this is a flame graph. So here you have the name of the thread. So there is two different threads. So here you have, in fact, the height of the flame graph is the depth of the stack, and the width is the number of profiles. So this is, as it's CPU profiling, this is the CPU usage of the frame, excuse me. What I really love about frame graphs is that you can zoom inside it. So for example, this is my bookmark resource method. So I can click it, and this will zoom inside my bookmark resource method, and I can see what's going on inside it. So I can see that all the CPU is used to access my database, and this is expected. So this is a normal profile. Great. So this is CPU profiling with perf, but I can also profile memory with perf. When I profile memory with perf, I will launch my application with perf mem record. I will not attach perf to running process. It's easier to do it like this. And I will again generate some load, so 10 second load. And after 10 seconds, I will close my application, and this will create the memory profile. Then I will be able to use flame graph to see this profile. Okay, so again, I will output the profile to a text file to be able to update it with set to remove the student name. Then I will use flame graph again to visualize the memory profile. If you already use a same profile also is able to generate flame graph for you. So this is when you use perf. If you used to use flame graph, you can use perf easily because it's the same kind of profile representation. Flame graph in both cases. So it will again take some time before I can use before I can generate flame graph. Okay. Great. I'm clicking to set command. Okay, and I generate a flame graph with the flame graph tool, and I open it in Firefox. So I have the same kind of representation. Again, I can zoom inside my bookmark resource, and I can see that my bookmark resource uses I selected the wrong. This is this one. Okay, so here I can see that again the memory is mainly allocated inside hibernate classes, so to load my information inside my database, but there is also some memory allocated to create metric ID. Okay, so this was F. So with native executables, you can use perf to profile CPU memory and a lot more. Perf is really a versatile tool. You can profile a lot of different stuff and get statistics, OS level statistics. You can use flame graph to display the profile. Your native executable must be built with these two options. So you keep local symbols, and you can use preserve frame pointer to have more accurate flame graph. And here I just give you my perf recipe if you need it. So last thing is how to debug your application. So it's really rare to need to use debugger on production. So you usually use debuggers and you develop your application. But if you need to debug your native executable, you cannot use a debugger from your IDE or conventional one because debuggers are based on GVM TI. but you can use GDB. GDB is GNU Debugger, so it's a standard debugger that you can use on Linux. To use GDB, you need to compile your native executable. You need to build it with debugging enabled. So I have an instance of my application built with debugging information. So I will use this one. And you need to have the source of the application available, and also the source of your dependencies if you need to. Okay, switch. Okay. But you can use npm dependency sources to download the sources of your dependencies. Then you'll be able to use GDB to launch your application. Okay. And you can see that GDB will read the symbol from my binary, so it's all good. And I will tell GDB to use the local sources of my application and the local sources of my dependencies. Then I can add a breakpoint. So I will add a breakpoint to an hello endpoint. Okay, so define the sources and add the breakpoint. Then I can run my application. Okay, and I can just make a curl on my application. So I make a curl on my application inside GDB itself. Okay, and GDB said that I am inside the hello resource file where there is a breakpoint. And it just outputs the line where the breakpoint is. I can have information about the running threads. Okay, and can also have some information about the current stack. Yeah, where the breakpoint is, and I can just go one step. But step by step inside my code, I can just continue to go to the next breakpoint, and it outputs, hello Loïc, this is the output of my resource. Okay, so this is it for GDB. GDB, you can do a lot of stuff inside GDB. If you need to use it, just check on its documentation. So to debug native executables, you can use GDB. Your applications and dependency sources should be available, and native executable should be built with debugging enabled. So to conclude, using native executables implies changing the tool we use to monitor and troubleshoot our applications. For statistics and metrics, you can use embedded tools like Prometheus or Microservices. For thread dump, use kill-3. For memory, you can use gslogs. For monitoring open tracing, for profiler, you can use Flame Graph. And for debugger, you can use GDB. Another solution could be to deploy both GVM and native executables. In traditional deployment, you deploy multiple time system components, so you can have one instance in GVM mode and the other as native executables. It's fine if you have, for example, 10 instances deployed. If you have just 2 instances deployed, this is not a good idea. So this is a valid approach, but the issue that sometimes you can have native-only issues, and with this, you really need to monitor and troubleshoot your native executable. So thank you. Again, if you want to contact me, you can contact me on Twitter or via my email. And now I will check if there is some questions. So, is there some questions?
Any questions? Yeah, I have one for you. don't see any questions, but I may have one for you.
Okay.
So my question is, how did you come? Well, you found out about these tools by yourself, right? And,
yes and no. In fact, I'm a Quarkus contributor, and there is some GraalVM contributor to inside the Quarkus community, and some of these tools I discovered them thanks to these contributors, like for example GD, and Perf is the tool I wanted to test for a long time. So yes, so I discovered it by myself. But I also have some help from Gator, from Quarkus community, from Reddit. Thanks to Gator, if he's here. I don't know.
maybe. Okay, I'm going to pull Oleg back there as well.
Hey.
All right, Oleg. Yeah. So that's the E2. If you want to conclude on anything, thank you very much for the 2 amazing talks. And I do hope that our attendees have had a thing or two. The rest, I know I did, so hopefully they did as well.
Thank you very much for inviting me.
Thank you.
All right, so I guess it's a wrap. If you want to send questions to the speakers, you can either do it in chat, or you can just email us directly through the meetup or wherever you have registered for the session. So thank you very much. Derek, if you want to say a word, I can put you back on the deck.
Thanks. Thank you for joining the session. I hope the session was informative. So I guess we will try to work out another session for everyone, maybe somewhere next year.
Definitely, that would be great.
Stay safe, everyone.
All right, thanks. And I guess that's a wrap. I will end the broadcast now. Thank you everyone for joining.
Take care, everyone. Bye-bye.
Take care.